On the morning of August 21st, a pair of jets will take off from NASA's Johnson Space Center in Houston to chase the shadow of the moon. They will climb to 15 kilometers in the stratosphere and fly in the path of the total solar eclipse over Missouri, Illinois and Tennessee at 750 kilometers per hour. But some of the instruments the jets carry won't be looking at the sun, or even at Earth. They'll be focused on a different celestial body, Mercury. In the handful of minutes that the planes zip along in darkness, the instruments could collect enough data to answer this Mercury mystery. What is the innermost planet's surface made of? Because it's so close to the sun, Mercury is tough to study from Earth. It's difficult to observe close-up, too. Extreme heat and radiation threaten to fry any spacecraft that gets too close. And the sun's brightness can swamp a hardy spacecraft's efforts to send signals back to Earth. NASA's Messenger spacecraft orbited Mercury from 2011 to 2015 and revealed a battered, scarred landscape made of different material than the rest of the terrestrial planets. SN 111911, p. 17. Story continues below. Video chasing the moon. A pair of NASA research planes with telescopes in their noses will fly in the moon's shadow on August 21st, extending the eclipse from 2 minutes to more than 6. NASA Goddard YouTube. But Messenger only scratched the surface, so to speak. It analyzed the planet's composition with an instrument called a reflectance spectrometer, which collects light and then splits that light into its component wavelengths to figure out which elements the light was reflected from. Messenger took measurements of reflected light from Mercury's surface at wavelengths shorter than 1 micrometer, which revealed, among other things, that Mercury contains a surprising amount of sulfur and potassium. SN 71611, p. 12. Those wavelengths come only from the top few micrometers of Mercury. What lies below is still unknown. To dig a few centimeters deeper into Mercury's surface, solar physicist Amir Kaspi and planetary scientist Konstantin Sang of the Southwest Research Institute in Boulder, Colorado, and colleagues will use an infrared camera, specially built by Alabama-based Southern Research, that detects wavelengths between 3 and 5 micrometers. Copies of the instrument will fly on the 2 NASA WB-57 research jets, whose altitude and speed will give the observers 2 advantages: less atmospheric interference and more time in the path of the eclipse. Chasing the moon's shadow will let the planes stay in totality, the region where the sun's bright disk is completely blocked by the moon, for a combined 400 seconds, 6.67 minutes. That's nearly 3 times longer than they would get by staying in one spot. Mercury's dayside surface is 425 degrees Celsius, and it actually emits light at 4.1 micrometers, right in the middle of the range of Kaspi instrument. As any given spot on Mercury rotates away from the sun, its temperature drops as low as -179 degrees C. Measuring how quickly the planet loses heat can help researchers figure out what the subsurface material is made of and how densely it's packed. Looser sand will give up its heat more readily, while more close-packed rock will hold heat in longer. This is something that has never been done before, Kaspi says. We're going to try to make the first thermal image heat map of the surface of Mercury. Unfortunately for Kaspi, only 2 people can fly on the jet, the pilot and someone to run the instrument. Kaspi will remain on the ground in Houston, out of the path of totality. So, I will get to watch the eclipse on TV, Kaspi says. Editors note this story was updated August 14, 2017, to correct the description of the instrument that will be used to study Mercury's surface.